First chapter, the chemical world. Soda Pop Fizz. So what do you call a fizzy, non-alcoholic drink? Soda, sugar water, yeah. But most people in California call it soda, right? I grew up in Minnesota and Iowa, and in Minnesota they call it pop. And I was just there this summer, and you go into the convenience store, and it's not the soda fountain, it's the pop machine. And the big cups actually say pop on them. And I've been away so long that was kind of a novelty. Soda pop just sounds kind of dumb, doesn't it? I think the author here is trying to cover the whole country, because in some places they call it pop, some places they call it soda. So I'm going to call it soda because we're in California. Personally, I like soda. I like that fizz. Well, chemistry tells us a little about what is in the soda. Soda is composed of tiny particles called atoms, which are very small, and that is a huge understatement. We'll learn in this class how very small atoms are. A single drop of soda contains about 1 billion trillion atoms. That's a billion trillions. That's if you took 10 to the 9 and multiplied it by 10 raised to the 12th power. That is a big number, right? We cannot get our minds around that. It's hard to get your mind around a billion, but a billion trillions, it's just mind-bogglingly. One drop of soda has that many atoms in it. Well, they're not all just swimming around as individual atoms. Some of them are stuck together by chemical bonds, and we're going to learn about chemical bonds in this class. When we have atoms stuck together with chemical bonds, we call them molecules. So here's an illustration of a water molecule. It has one oxygen atom, and 2 hydrogen atoms, and they're stuck together. Kind of looks like an upside-down Mickey Mouse head to me. What is very important to recognize is that all matter is composed of atoms and molecules. Soda is composed of atoms. The air that we're breathing is composed of atoms. The chair that you're sitting on is composed of atoms. Your body is composed of atoms. So atoms are pretty important. Soda is a mixture of carbon dioxide molecules and water molecules, along with a whole bunch of other substances. Water is the main part of the soda, the liquid, and the bubbles, the fizziness, is the carbon dioxide molecules. They form little tiny gas bubbles that tickle your tongue when you drink it. So here's an illustration, and here we see the little water molecules, and these are the carbon dioxide molecules. So carbon dioxide molecules have 1 carbon atom and 2 oxygen atoms. They're kind of similar to the water molecules, but the water molecule is 1 oxygen and 2 hydrogens. The other substance in the substances give it the sweetness, the color, and the flavor. But most of it's water, and the bubbles are carbon dioxide. So here's better pictures. Here's the carbon dioxide molecule, 1 carbon, 2 oxygens, like I said. These 3 atoms are stuck together, chemically bonded together in a straight line. A water molecule is also composed of 3 atoms, this time 1 oxygen and 2 hydrogens. But instead of being in a straight line, this molecule is bent. The study of chemistry tells us why the one is straight and the other is bent. And the shapes of these molecules have a direct impact on their characteristics. And so that becomes very important in how does this substance behave? Well, how it behaves, it is directly affected by what the individual particles, the molecules, are like. So, under pressure, having troubles with my pointer, there we go. Under pressure, gaseous carbon dioxide molecules are forced to remain mixed with liquid water molecules in a sealed container. I think we all know from experience that if you have a 2-liter bottle of soda and you never open it, it'll stay fizzy for months. You could wait 6 months and you open it and it still makes that wonderful psh sound. That sound is carbon dioxide gas escaping from the container. But we also have observed that if you leave soda in an open container, it doesn't stay fizzy for very long. Usually by the next day, it's noticeably flat, and within a couple of days, it's completely flat. There's no bubbles in it anymore. There's no fizziness. It's just like bad Kool-Aid at that point. So what happens when you open the can is that the pressure is released. All soda containers, whether they're bottles or cans, have a little airspace above the liquid, and that is pressurized with carbon dioxide. When you open the can or the bottle, you hear the psst sound, and that is the gas pressure escaping. As that pressure is released, the carbon dioxide molecules that were forced down into the liquid can begin escaping. And then that creates the bubbles. So you open a can of soda and you see bubbles start to rise. They didn't do that before. They had nowhere to go. So that's kind of like, I don't know, there's probably supposed to be a conclusion to that, but I can't think of anything else to say about it.